Today we're going to work through some Boyles Law problems. So first let's discuss what Boyles Law can be used for. So Boyles Law is used when pressure is changing for a gas, and when you change the pressure, it changes the volume. Temperature is not changing in Boyles Law problems. So temperature is constant. That means not changing. So there's no T in Boyle's Law. There's no temperature because it wouldn't belong in there since it's not changing at all. So it's not going to impact the problem. So if you're looking at a problem and it gives you a beginning and ending temperature that are different, or it gives you a beginning temperature and asks for an ending temperature, or vice versa, then this is not the law to use. You only use this when pressure and volume are changing. So Boyle's Law actually says that pressure times volume equals a constant. But the way that we're going to use this is to figure out either pressure or temperature when the other one changes. So we're going to actually use it in this form. So your starting conditions, pressure 1, volume 1, that's our beginning conditions. And sometimes you have to read a problem pretty carefully to figure out what are the beginning conditions. And that's equal to pressure 2 times volume 2. These are our ending conditions. You will be given 3 of the 4 variables. So let's look at some problems that would fit into this type. Here's the problem that we're going to solve. What is the final volume of a gas sample that is 455 milliliters at 1.2 atm if the pressure is increased to 2.0 atm? So first of all, we know we have pressure and volume variables. So you look at the labels on those to figure out what's what. Milliliters is a volume. ATM stands for atmospheres, and those are pressures. So we know that there's a P1, a V1, a P2, and a V2 in this problem. It's asking what is the final volume. So final volume is V2. So that's going to be our X. That's what we're asked to find. It doesn't matter what the gas is. It could be carbon dioxide. It could be hydrogen, nitrogen, any number of gases. All gases work the same way. So that's the beauty of the gas laws, is that you don't have to actually know what the particular gas is, or there could even be a mixture of gases. So it says that the volume is 455 milliliters, so that's V1, at 1.2 atmospheres, that's our P1, if the pressure is increased to 2.0 atmospheres, so that's our P2, because that's our final pressure. So remember, P1, V1 equals P2, V2. Pressure 1 is 1.2 atmospheres. Volume 1 is 455 milliliters. It doesn't matter if it's in liters or milliliters as long as it's the same on both sides. Pressure 2 is 2.0 atmospheres. And volume 2 is our X. And to figure out what units that will be, look at volume 1. So since volume 1 is in milliliters, our V2 is going to come out in milliliters. On the left side, we have 1.2 times 455, which is 546. On the right side, we have 2.0x. Now to get x by itself, since it's 2 times x, we're going to have to divide by 2, which means if you do it to the right side to keep it equal, you have to do it to the left side. This one cancels, so we just have x on that side. And now we take our 546, we divide that by 2, and we get 273. So our x is equal to 273 milliliters, because that's what our other volume was in milliliters. So our x is going to come out in milliliters. Lastly, if your teacher wants you to do significant figures, if we go back and look at the problem, this number has 3, this number has 2, this number has 2. So our final answer should have 2. Whichever one has the least influences what the answer will have. So we would round that to 270 to have just 2 sig figs milliliters. If your teacher doesn't care about significant figures or doesn't require you to do that, then you can stick with the 273. Let's look at another problem. This one's asking, what is the pressure on a 500-liter container of hydrogen gas if it has a volume of 450 liters at 235 kPa, kilopascals. So kilopascals are another measurement of pressure, just like atmospheres was in the last problem. Your pressure may be measured in kilopascals, atmospheres, millimeters of mercury, or torr. So any of those 4 units you may see for pressure. Volume is usually going to be in either liters or milliliters. In this case, it's in liters. So it's asking the pressure on a 500-liter container. So this pressure and this 500 liters goes together. If it has a volume of this 450 liters at 235 kPa. So this goes with this one. So our 450 liters goes, so if I pick that as 2, then my pressure 2 is what goes with it, so 235 kPa. We're asked for the pressure, so this is our x. Its units are going to be kPa because the other pressure units are that. And its volume at this unknown pressure is 500 liters. So remember, P1V1 equals P2V2. So we're going to have x kPa times 500 liters equals 235 kPa, 450 liters. Notice your volume is both in liters, both of these are in liters, and both of the pressures are going to be the same in kPa. So on this side, we have 500x. On this side, we have 235 times 450, which is 105,750. Now to get the x by itself, since it's 500 times x, I need to divide by 500. If I do it to the left side, I have to do it to the right side to keep it equal. So here my 500 cancels and I just have x. And here I'm going to take 105,750 divided by 500, which is 211.5. And if I look back here, I was solving for pressure and my units are kPa. If your teacher doesn't care about sig figs or doesn't require you to do it, you're done there. if you do have to do sig figs, this number has 4, this number has 4, this number has 3, so our answer gets 3, so we're going to keep 2, 1, 1, but since that's a 5, we're going to round up the last digit that we keep, and so this would be our answer with the correct number of significant figures. We're going to look at one more problem, and in this problem our units don't match up, so we have to do a conversion. Our question is, a 250 milliliter gas sample at 780 torr has what volume at 1.5 atm? So we need to decide, do we want to change atm to torr or torr to atm, because these are our pressure units and we can't just plug them in the way they are. The pressure units have to match. So I need either both of them to be in torr or both of them to be in atm. So a 250 milliliter gas sample, so that's volume 1, 250 milliliters at 780 torr. Torr is a fancy name for millimeters of mercury. So if you haven't seen torr, it's the same as millimeters of mercury. Pressure 2 is 1.5 atm, atmospheres, and we're asked for the volume. We'll have what volume? Now our volume is going to be in milliliters because this given volume was in milliliters, so our final volume is going to come out in milliliters. But we've got to fix this torr atm problem. It doesn't matter which one you convert. So I'm going to go ahead and convert my torr into atm. So I have 780 torr, and my conversion factor, there's 760 torr in 1 atm. So I need to take my 780 and times 1 divided by 760. So 780 divided by 760 gives me 1.03 atmospheres. So for your conversions between volumes, 1 atmosphere is equal to 101.3 kilopascals is equal to 760 torr, which is the same as millimeters of mercury. So, oops, HG. So since we had torr and atm, we had to use torr atm, this conversion factor. 1 atm is 760 torr, and since we were given torr, in order to cancel that unit, we had to put it on the bottom and put our 1 atm on top so that that unit cancels, and we're just left with atm in our final answer. So now to work the actual problem, P1V1 equals P2V2. P1 is now 1.03 atm. V1 is 250 milliliters. P2 is 1.50 atm. And V2 is X. So 1.03 times 250 is 257.5 equals 1.50x. To get the x by itself, I need to divide by 1.50. 1.50 on both sides. This one cancels. On this side, we get 171.6 repeating equals X. 4 sig figs, 4 sig figs, 3 sig figs. Don't use your conversion factors when figuring this out. Just use your original problem. So we want to keep 3. So our answer is going to be 172, and we're solving for volume in milliliters. And that's our final answer. I hope this tutorial has helped and that you have great success with these problems. Thanks for tuning in. Please like and subscribe.